Orientation effect of substituents in electrophilic substitution reactions. When a mono-substituted benzene is subjected to electrophilic substitution reactions like halogenation, nitration, sulfonation, etc., three isomeric substitution products are theoretically possible. In this formula, G stands for a group like alkyl group or a functional group. That is, G is equal to groups like CH3, CH2, CH3, etc. or functional groups like OH group, COOH group, etc. This type of compounds are called mono-substituted benzene. G equal to an alkyl group or a functional group. When this compound is subjected to electrophilic substitution reaction like nitration, three isomeric substitution products are theoretically possible. The nitro group may be on adjacent carbon atom, that is ortho substitution product. The nitro group may be on alternate carbon atom, that is a meta substitution product. The electrophile may be at para position. So, three types of isomeric substitution products are theoretically possible. When a mono-substituted benzene is subjected to electrophilic substitution reactions like nitration, three isomeric substitution products are possible. They are ortho, meta and para. Experimentally, it is found that in the case of certain groups, only a mixture of ortho and para substitution products are obtained. And in the case of some other groups, it is found that only meta substitution product is obtained. Accordingly, groups bonded to benzene ring are classified into two types. First one, ortho-para directing groups. Ortho-para directing groups. These groups, when attached to benzene ring, substitution always take place at ortho and para position, irrespective of the nature of electrophilic substitution reaction. That is, whether it is halogenation or nitration or sulfonation, in all cases, product is a mixture of ortho and para isomers of substitution product. Second is meta-directing groups. Meta-directing groups. These groups, when bonded to benzene ring, only meta substitution product is obtained during all electrophilic substitution reactions. This directive influence of groups is called orientation effect of substituents. Orientation effect of substituents. In the case of ortho-para directing groups, the group increases electron density at ortho and para position. So, electrophile like nitronium ion approaches ortho and para carbon atom, giving a mixture of ortho and para substitution products. In the case of meta-directing groups, the groups decreases electron density at ortho and para position. Then the electrophile is forced to approach one of the meta position in the aromatic ring, and hence meta substitution product is obtained. Ortho-para directing groups increases electron density at ortho and para position in the benzene ring either through hyperconjugation or through positive resonance effect. It is also called a plus mesomeric effect. The groups that are increasing electron density at ortho-para position in the benzene ring are called ortho-para directing groups. Examples for ortho-para directing groups. First type, alkyl groups like methyl group, ethyl group, propyl group, etc. This type of alkyl groups, when attached to benzene ring, electron density at ortho and para position increases through hyperconjugation. Hyperconjugation is a special type of resonance involving sigma electrons of carbon-hydrogen bond and adjacent pi electrons. This type of resonance is called hyperconjugation. In this resonating structure, lone pair electron is localized on ortho carbon atom. As the sigma electrons are shifted to here, this hydrogen atom remains without any bond. So this type of resonance is also called no bond resonance. Hyperconjugation or no bond resonance. So these are the hyperconjugative resonating structures of toluene. The lone pair is shifted to here, pi electron is shifted to next ortho position. This type of resonance is called hyperconjugation or no bond resonance. In these resonating structures, negative charge is localized on ortho carbon atom, para carbon atom, ortho carbon atom. In other words, CH3 group increases electron density at ortho and para positions in the benzene ring. So when it is subjected to electrophilic substitution reaction like nitration, the nitronium ion approaches either ortho position or para position, giving a mixture of ortho and para substitution products. That is, a mixture of ortho-nitrotoluene and para-nitrotoluene are obtained. When toluene is subjected to nitration, that is on heating with concentrated nitric acid, concentrated sulfuric acid mixture, the product obtained is a mixture of ortho and para nitrotoluene. Due to steric effect of this CH3 group, approach of nitronium ion to para position is energetically favorable. Hence, major product is para nitrotoluene. So CH3 group is a ortho-para directing group. When toluene is subjected to bromination with bromine and ferric bromide, a mixture of ortho-bromotoluene and para-bromotoluene are obtained. Here also major product will be para-bromotoluene. If it is a ethyl group, one of this hydrogen atom will be CH3. Then in all resonating structure, this hydrogen atom will be CH3. Within the ring, there is no change. That is, ortho and para carbon atom have a negative charge. That is, ethyl group is also increases electron density at ortho and para position. Similarly, all alkyl groups increases electron density at ortho and para position through hyperconjugation.